Well, we're looking at section 7.3, where we're looking at dimensions that aren't integer dimensions. So here you see a picture of cloud-like platonic solids, fractals whose dimension is between 2 and 3. We're looking at other dimensions, though. Did anybody have homework questions? So I'd emailed a few homework questions, so let's talk about those. I'd gotten asked a few questions earlier, so I'll go ahead and pick those out. I'll have to adjust chapter 8 too. Chapter 8 won't be due this weekend on here. I have to change that due date. So let's see, I was looking at this one with the Koch stool. So the Koch stool is similar to the Koch curve in that the middle third is taken away, but on the Koch curve we made two sides of an equilateral triangle there. With the Koch stool, you put three sides of a square there. So this is the first iteration of the Koch stool. The next iteration, you would shrink this down and place it on all 5 of these line segments. So I have some images here. So here's the next iteration where you've shrunk that Koch stool down and placed it on all 5 of the line segments. And then future iteration, you would take this shape again, shrink it down, and put it on each of these. And that would be this iteration. So this is the first stage, and it gets shrunk down and put on each of these line segments. So the question is, what is the dimension of the Koch stool? So first you have to decide how many copies are needed. So if you shrink this down and place it on each of the line segments, how many copies are you going to do that with? Anybody? So you place 1, 2, 3, 4, 5 copies. Okay. And then we need the scaling factor. How much bigger is the Koch stool than the largest piece that you're using? So here you might think of this piece. You take this piece, or here you can see it's this piece. This piece looks like the whole Koch stool. At any rate, if you took a ruler and measured the whole thing and then measured this piece, you see that it's 3 times as big, right? The whole thing is 3 times as wide as just this little piece that looks like the whole Koch stool. So this piece of the Koch stool looks like the whole thing. So scaling factor is 3. The scaling factor is 3, number of copies 5. And we had s raised to the d equals n. Now you would just fill in there, the scaling factor is 3. We're trying to find the dimension, and the number of copies 5. And then you can use your calculator and work to find out what that dimension is. So it's bigger than 1 because 3 to the 1 is 3. And plus you can see it's more than a line. But it's not 2 because 3 squared is 9. So it's not 2-dimensional. It's somewhere between 1-dimensional and 2-dimensional. Let's try 1.5. It's a little bigger than 9. Bigger than 5. We're trying to get a 5 out of this. 3 raised to what power equals 5? So something between 4 and 5. That's closer. I'd like it if you got within 1/100th, okay? So that's too big. It's a little better. About 465. There we go. 3 raised to the 1.465. So D is 1.465. Now you'll have a number of problems on your homework where you're trying to find dimensions. So you might want to go directly to using a calculator that has the natural log on it. So instead of using this, we can say, or natural log of n divided by natural log of s. So for a quiz, this is fine to try the guess and check method, but on Wiley Plus, you have to get within like 1/1000th correct. So you might want to just use this little formula. So here, for example, I would have had natural log of 5 divided by natural log of 3. So rounding to 3 decimal places, I have 1.465 there. I had told you on Monday that we would go ahead and take a look at the Koch curve. Yes, questions?
I had questions on 7.2's homework.
7.2? Okay, let's look at that.
Which I remember what they- Because I got everything, like, I think it was Mindscape 3. So I got every number except for the bottom one because I don't know exactly what they're asking for.
Sure. Let me make this smaller so it shows.
I know the answer, I just don't know how to put it in.
Sure. Let's see if we could, if it will show on here. Where'd my cursor go? There it is. Okay, so allow okay, so this is gone. I think number 4 is along the same line. So I'm going to use number 4 because, okay, here's where you click right here.
Mm-hmm.
And
I
then
tried putting 3, but then I didn't know exactly.
pick the square root symbol right here. So pick the square root symbol, and under the square root symbol, there's the exponent. So box raised to the box. So I don't know what this one is, Koch curve. Well, at any rate, this is the choice that you pick. So under the square root symbol, box raised to box. Okay?
And then for 7.2, Mindscape 21.
21.
I just have no idea what it's asking me.
Okay, so I think everybody might have a different picture here.
Mm-hmm.
So this is the Koch stool. For iteration blank. Okay, so the first iteration, it sounds like, is this one right here.
Mm-hmm.
Okay, and this would be the second iteration, because then this shape is put on each of these.
Okay.
And the next iteration, if you have another iteration, will have little tiny Koch stools on each of these. So let's see what I have on mine. This looks like iteration 2. Unless they call it's just hard because sometimes they call stage 0. Sometimes they call this stage 0, and sometimes they call this stage 1. So it's gonna. I think mine will be 1 or 2, depending on which is the case. So let's see what mine is.
2.
This one's 2?
It doesn't have the same one.
You have the same one? Okay, thank you for letting us know. Okay, so evidently this is 2, and if you have the next one up with a little tiny Coke stool here, and here, and here, that will be 3.
Okay.
Okay. Any other questions? Yes?
The one above it.
9? Okay. Oh, so this was like what we see when we turn on the camera here in class, isn't it? And you see the screen repeated in the screen, repeated in the screen. And the answer here is infinitely. So you infinite. Is there an E in infinitely? There is an E? Thank you. Okay. Anybody else have questions? Okay, well then I thought we would take a look at the Sierpinski carpet. So on your quiz you will be expected to find the dimension of a fractal. So we've looked at the Koch curve, the Sierpinski triangle, and now we'll look at the Sierpinski carpet. So the Sierpinski carpet has the center square removed. So here's 3 iterations of the Sierpinski carpet. So this center square is removed. The yellow lines are added just for you to see that it is in fact in the middle. And then this shape is shrunk down and placed in each of these squares around that are implicitly defined by that square being taken away. So the square is shrunk down and placed here, 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 and here. And then that happens again. So this square is shrunk down even further and placed around each of these other empty yellow spaces. So at your desk, go ahead and write down the scaling factor. Okay, how many times? I think it's easiest to focus on the middle one for this. How many times bigger is the whole carpet compared to this little one that's being used if you were to measure it with a ruler? Okay, so the scaling factor is if you take a ruler and lay it down across the whole thing and compare it to this little piece that's has the whole carpet within it, how many times bigger is it? So that's the scaling factor. So I heard some of you say it, it's 3 times bigger, isn't it? Okay, so if you counted the little squares, the whole carpet is 9 little squares across, and this little corner that's being used to make copies is only 3 squares across. So scaling factor 3, and next write down the number of copies that you'll need of that little square. So how many copies of that little square do you need to put together? Remember, the yellow's empty. So how many copies of that little square do you need to build the Sierpinski carpet? How many did you decide? Anybody? Anybody know how many copies of that? Yes. 8. That's right, 8. 1, 2, 3, 4, 5, 6, 7, 8. So let's see what the dimension is here. So the Sierpinski carpet dimension, we have 8 copies. So 8 is n number of copies. 3 is the scaling factor. The large carpet is 3 times as large as the little one. We have s to the d is n. So 3 raised to the dimension is 8. So this time we'll need an exponent closer to 2, right? Because 3 squared is 9. So I'll start with 1.75. So between 1.8 and 1.9. So I'm doing that on this kind of calculator because some of you don't have a calculator with natural log, and so I don't want you to have to use that natural log formula. But if you want to use this formula instead, it's quicker. Gives you the answer right away. And in class, I didn't want to talk about natural logs too much either because we didn't have that as a prerequisite for our class. Okay, so once you get within 1/100th of the 8, then you're good. So I'm saying 3 raised to the 1.895. If you want more degrees of accuracy, you can use this formula. Well, this is as far as my voice lasted this morning. Since then, I've discovered secrets, so my voice would go a little longer. My tongue is numb, but that's okay. But because this is where I stopped in the first class, we'll stop here. And then on Friday, we'll take a look at the fractals in 7.4. Also, bring a deck of cards Friday, please. We'll need them either Friday or Saturday for Chapter 8. And then Chapter 8 won't be due until the following week, okay? I'll see you on Friday. Excuse me.